Unit 7, Complex Quadratics and Functions, practice test. This is the back page. The front page is a different video. So we have find the discriminant in number of real solutions. So if you remember, the discriminant is only what's inside of the square root in the quadratic formula. So the only numbers we care about is the b squared minus 4ac. So in this question, make sure that you identify your a, b, and c. Make sure it's in order. So this is our a, our b, and our c. And then put the numbers into the right spot. So our b is 2. So we get 2 squared. And we actually don't even need the square root parts. It's just this. All you need is this. So we get 2 squared minus 4 times our a, which is also a 4. This one's positive. And our c is negative 7. 2 squared is 4. Negative 4 times 4 is negative 16. And then negative 16 times 7 is 112. Positive 112. 4 plus 112 is equal to 116. That is our discriminant. That is the answer for this first part. The number of real solutions. This answer is dependent on this number. If this number is positive, then it is 2 real solutions, which is our case here. If it is 0, then you have 1 real solution. And if it is negative, then you would have 0 real solutions. So in this case, the number of real solutions is 2 because our number is a positive 116. Divide the complex number. So we need to look at our denominator. Make sure it is written in the correct way, which has our I second. So it should be negative 8 plus 4i. We should make that change first. And now we need to multiply by the conjugate, which is we change this sign to the opposite sign. So this was positive, so now it's going to be negative. So we multiply the top and the bottom by negative 8 minus 4i, and the bottom is negative 8 minus 4i as well. And now we have 2 different problems or multiplications we have to work on. Let me erase that just for space. Let's do the top first. So I have a box here, 5 minus 3i, and negative 8 minus 4i. Negative 8 times 5 is negative 40. Negative 8 times negative 3i is positive 24i. 5 times negative 4, negative 20. There's an I in there. It looks funky. Sorry, let's see if I can erase that out of there. There we go. I. And then finally, negative 4i times negative 3i is positive 12i squared. And the 12i squared becomes a negative 12 because that I squared becomes a negative 1. And that changes our positive 12 to a negative 12. Now let's add like terms. So negative 40 minus 12 is negative 52. And negative 20i plus 24i is positive 4i. Now for the bottom, our denominator. Okay, you can flip the denominator like we did before, or we leave it the way it was written. Either way, you get the same answer. So 4i times negative 8, negative 32i. 4i times negative 4i is negative 16i squared. Negative 8 times negative 8 is 64. And then negative 8 times negative 4i is positive 32i. I just thought, there you go. Sorry, I was saying I squared for a second, but it's not. These cancel out, which you should have something cancel out when you're doing this every single time. And then our negative 16i squared turns to a positive 16. So positive 16 plus 60 gives us a positive 80. And all 3 of these numbers we divide by 4. So you can simplify to negative 13 plus I all over 20 will be your final answer. Oops. Did not move. There we go. That works. Okay. Find the inverse of the following functions. And then we have to graph an inverse function down here. So whenever we do the inverse, remember you're flipping your x and your y. So we get an x is equal to 5y plus 2. And now we need to solve for our y, meaning put our y by itself. Go away. There we go. First thing, subtract 2 from both sides. So we get x minus 2 is equal to 5y, and then divide by 5. So y is equal to x minus 2 over 5. Do it again down here. Flip your x and your y. So we get x is equal to 5 times y plus 3. That's a 3. First step here is divide by that 5. On both sides. So that cancels off with that. So we get x over 5 is equal to y plus 3. And then finally subtract 3 from both sides. So we get x over 5 minus 3 is equal to y. Those are our two answers for those. Now we need to graph the inverse function. So all we need to do is find the coordinates of 2 points. To change this to blue. 1 point here, which that point's coordinate is 1, 0. And this point down here, which is -1, -6. Now the inverse of this, I'll do it in bright green. Each of these points, we got to flip their locations or their numbers. So 1 point will be 0, 1, and the other one will be -6, -1. 0, 1 is here. -6, -1 is there. And then you just connect your dots. And that is the inverse function. All right, now we need to state the positive, negative. There's a lot of questions here. We have a positive, negative, increasing, and decreasing intervals, as well as a relative minimum and relative maximum. So let's go in order. Positive intervals. So positive intervals is all the spots of the graph that's above our x-axis. So we have this is a positive interval, and this is a positive interval. So here is our x value for the start of that. So we'll just put that in here. -2.732 is less than, actually it's also equal to, and our interval goes all the way to -1. Okay, that's one of them. And then our other positive interval, put a comma, is 0.732, less than or equal to x, and this goes to infinity. Okay, let me erase my work up here so nothing's distracting. Now the negative intervals is very similar to the positive intervals, but it's everything that's below the graph, or below the x-axis. So we have from negative infinity to -2.732. So negative infinity, x, -2.732, comma, and then our other negative interval is from -1 to 0.732. So -1, 0.732. Okay, a couple more things here. Now, increasing interval is where our graph is going upwards. Let's do one in blue. So our graph is going upwards all the way until we get to here. And also, it goes upwards from here all the way up to there. So we have two increasing intervals, negative infinity, x, and our x value is -2 up there. And our other increasing interval is from 0 to infinity. 0, x, infinity. And what's a decreasing interval? So there's only one on this graph. I'll do a different color. Let's see here. We'll do it in nice brown. It's our only decreasing interval from -2 to 0. -2 and 0. And that's it for that one. Now we have 2 more questions left, a relative max and a relative minimum. There's one of each. Well, I guess I'll do it in black. That's our relative max. That's our relative minimum. It's where the graph changes directions. So -2 and 2 is, oh, actually that's a max, sorry. So this one's our max, so that's our second question. Oh, I typed this in wrong. I'm going to pick this on the actual question. This will be a max on your sheet. Didn't catch that. So max was it 2, -2? Sorry, -2, 2. -2, comma 2. And our relative minimum is 0, comma -2. And that is the rest of our practice test. We are done.